Hey, Jeff here, and I want to talk about a little experiment I did with dynamic temperature intra-response modification called thermostat. Just because everything has to have a pun, and a thermostat changes the temperature. So it's basically dynamic temperature control for LLMs that attempts to basically simulate changing the temperature within a single response. So, if you're doing some huge one-shot prompt where you have an ideation phase, more concrete example phase, and then maybe a summary phase. What if you could actually change the temperature, or the model could decide what temperature to use for each sort of section of that response? An interesting idea that my wife actually asked me while I was forcing her to watch yet another video on how LLMs work is she was noticing this whole temperature thing and said, oh, could you change it for different parts? And I sort of thought, never thought about that. Let's just do a quick overview of what temperature is. People like to sort of like align it with the notion of creativity, but what it basically is it's like a probability distribution essentially. So when the temperature is high, it means that the probability distribution of the next token to be selected is more sort of even across all possibilities. When the temperature is low, that basically means it's much more precise and that you'll usually have a small number of tokens that have extremely high probability, and then the rest fall off with extremely low probability. It's not magic, it's just math, but that math sort of tends to correspond to what people deem as creativity. Normally, just because, when you're being creative, you want to think outside the box, what hasn't usually been chosen before. And LLMs are, as many people like to say, glorified autocomplete. So, of course, it would make sense that you're going to autocomplete at a low temperature with a much more often used word than one at a high temperature. So the thermostat solution attempts to, via a system prompt and tool calls, simulate changing the temperature at different points in the response. So what we basically do is we give it a system prompt, sort of telling it what's up, saying, you're your usual self, Mr. Model, with the exception that if you deem what is coming in your response to require a different temperature than the one you're currently set at, which is, told in the initial prompt, then you can basically use this tool, which we provide, called change temperature, and then call it with the desired temperature, as well as a short reason for why you think the temperature needs to be changed. At which point, you will truncate the response early with a token, and then in the loop that I made, which is basically then going to call the LLM again, it's going to take the new temperature and actually insert that into the API call, as well as give it the entire context of what it was outputting with a continuation token and instructions to begin exactly from that continuation token. Then it, of course, merges the response subsequent to that, and if it requests temperature changes again, it will then do that, with a few exceptions that we'll go over in a second. So let's just kind of go over what that would look like. So a true intra-call temperature change doesn't really exist as far as I know. It sort of requires modifying the inference loop midstream. I have seen maybe like OpenAI sort of alluded to that in their GPT-5 demo. But one thing that I've noticed is a lot of software developers who might be very, very experienced in the software field, but sort of LLMs exist as a black box to them. They often say, oh, you know what? When I'm doing ideation, I always like talking in the ChatGPT web interface or the Claude web interface, and then, of course, implementing in Claude Code or Codex. What they actually might be sort of deriving benefit from is the higher temperature and the higher associated creativity, for lack of a better word, in those interfaces, and then the precision that comes with a agentic coding tool, which probably sets its model to a lower temperature in its API calls. So what Thermostat attempts to do is define in the system prompt call boundaries, which are logical points in the response to change the temperature. So, the instructions are like, don't do this mid-sentence, do it at a natural point where there might be a segue from one section to another, or the requirements of the text might be different than the text prior. So to sort of give like a literary example, imagine you want the craziest story of the craziest person in the entire world, the person you never thought, or maybe it's an alien, being sworn in as president. Perhaps you want the temperature extremely high so that you can sort of get these zany ideas about who's being sworn in. But when they're actually raising their right hand and taking the oath of office, you of course want the actual oath of office, I do solemnly swear to execute the duties faithfully or whatever, verbatim. So you'd want to lower the temperature for that. Sort of a silly example, but I think it really illustrates like when you might want a lower temperature versus a higher within the same generated response. And I actually sort of generated a bunch of situations to see if the model would, number one, take the hint or sort of guess, maybe I should lower or raise the temperature here, as well as see actually how effective it was. I'll go over those examples later, but some of them are like write a poem and then analyze its, pentameter, its structure, things like that. Poem writing, obviously, high temperature, and then the analysis, lower temperature. And for the most part, it understood that that's what it probably should do, and it outputted that reason accordingly in the reasoning. So yeah, as I alluded to, the natural boundaries, you basically have these tags for the end of ideation, and then sort of the prompt to call the tool and then begin generating on the next call with the newer temperature. So let's also just talk about the KV cache impact, right? Because one of the reasons why LLMs inference has gotten cheaper, in addition to just better training, is that their compute overhead is reduced when you have KV cache. And so you'll often notice, like when you're seeing how much money you just burned with the response, you'll see a certain amount of tokens were cached, which are sometimes charged for free, but usually just at like a lower rate, which is often awesome. This kind of has to throw away that entire notion because you're not going to have a cache hit when there's a new temperature being called. I kind of just did an experiment, and like by definition, if you're calling with a new temperature, it's not even going to bother reusing any sort of cache. It'll basically treat it as like an entirely new call with context that you pre-filled in, the context being the previous chunk of the response. So, if this were to actually be something people would want to use, things would have to be changed on the provider end, but I just really thought this was a really cool experiment to do. And so, yeah, with a lot of these like Chinese open source models, it's really a non-factor. If you get like the ZAI GLM coding plan or something like that, like that's what I've been using to experiment with it. Shoots AI is also super, super cheap. You can kind of get away with just spamming it with calls if you really want to experiment with this. And not having to pay like a huge financial penalty. It's like $10 a month for I think 1,000 or 2,000 calls a day or something crazy like that. So the hardest problem in all this, though, was the append-only guarantees. As we know, models as they get to higher and higher temperatures tend to become more unpredictable. And while we want things to accordingly be like at a higher temperature when we set them to a higher temperature, the one thing we don't want to be unpredictable is that it needs to just gracefully continue from where it left off in terms of generating the text. So, we were sort of faced with this problem where it's like, do we want to just really summarize what it was saying and give it the last few words, say continue from here? No, because that's not really simulating what it would be like to have an intra sort of response temperature change. So the real difficult part came from basically forcing it to really use the verbatim text that it was given and then continue it naturally and logically when the temperature was high. When it was low, no problem. It follows that instruction in the system prompt very, very well. When it's high, it became a little bit difficult. So we sort of had to do a overlap detection and then also try to repair in the response if something wasn't quite right or didn't quite overlap, or it added, an errant like continuing from here, ... or something, which you, again, explicitly told it not to do, but high temperature is high temperature and it does what it wants. In addition, anti-thrashing policies, right? So we don't want it to just be changing the temperature every 5 tokens for fun. We want there to be, number one, a genuine reason, and including that requirement in the tool called the change temperature helps ground the LLM to that reality. But number two, we also just set a hard cap on thrashing and also a minimum tokens generated between the times the temperatures are changed so that we can actually just enforce that programmatically when calling the LLM. So the system architecture looks like this: 5-layer modular design. The streaming coordinator is basically just like a proxy, like you, the user, are calling it like you would any other LLM. And then the orchestrator is the main event loop that handles all of the reconciling of the chunks of text, calling the LLM with the new temperatures once it returns it, either omitting the tool calls if it's done too many temperature changes, or, saying no, no, no if it sort of did too many in a row, depending on the model. And then we have the provider adapter for OpenAI and Anthropic, so it works with both formats. And then the validator pipeline, which is sort of an abstraction from the orchestrator that works on the overlap and the repeat detection and tries to merge it. And then just telemetry for event logging and metrics, which was super, super helpful when actually just trying to debug why certain models were not playing along with this. And it actually turned out, like for GLM, for example, it wasn't enough if it basically called temperature change, temperature change, temperature change like 3 times in a row without generating any text, which kind of ironically would happen at a higher temperature. We actually just had to yank the tool from the array in the next sort of call to that, so that it wouldn't even know that's a possibility, because it really seemed to like that at higher temperatures, the ability to change the temperature. And then we have 2 execution modes. Batch mode, which is like full validation before yielding the response to sort of be parsed by the pipeline, does have higher latency. The correctness is higher. And then the incremental mode is like literally just using the stream buffer as it comes in, lower latency for your eyes, but then there's also this best effort correctness, which is kind of a disaster. Because this is an experiment, I really preferred the batch mode to actually get like cohesive responses here, which I'll share with you soon. So the real world example, so here are some examples. I wrote some sample prompts that I thought would lend themselves well to temperature change. And in fact, they did. These were all generated using GLM 4.7. So the first one here is basically brainstorm then spec. What it is brainstorm 10 unconventional ideas for mobile app that helps people sleep, be creative and don't self-center. So obviously a very high temperature activities. Then pick the favorite idea and get into boring mode, low temperature mode, write a precise technical specification. So I didn't ever actually specify switch to this temperature for this. It is, again, its own volition. So what you can see here is right off the bat, it actually decided to up the temperature from the default of 0.7 all the way to 0.95 before it even started. It knew that it wanted to start the creative brainstorming phase. This was the reason that it gave, which is required for grounding and for insight and observability. So it came up with these 10 concepts. It selected one, at which point then it decided to lower the temperature to 0.1 for transitioning to precise technical specification, exact structured output, which it then proceeded to do. Another one was for drafting API and then security review. So basically designing a simple REST API for a to-do list app. Then from there, auditing the API itself. Again, all within one shot. And what we have here, it started at 0.7. It was okay with that. It basically generated all of the endpoints, the schemas, yada, yada, yada. At which point, for the security audit, it actually decided to go down to 0.1 because it needed a precise technical analysis with no ambiguity and structured vulnerability classification, which it actually did. So SQL injection, broken auth, and broken access control. For guess and verify, I gave it a mystery function. That's Python code. It's essentially just a sort of Fibonacci variation. So here we go. So it actually initially wanted to go up to 0.9 right off the bat with gut level brainstorming. It was the Fibonacci sequence. It had an exponential time complexity, and the base case handles negative inputs poorly. So it really wasn't even necessarily like brainstorming, I guess, but it then for the systemic verification to sort of verify these very creative intuitions, it dropped all the way to 0.1 for precise tracing and complexity analysis, which you can even see it did fancy big O notation, time complexity, and then yes, the verdict's confirmed. The base case logic catches negatives and returns them as is, which is likely a logical flaw. Next one is for implementation and critique. So basically implement a Python function as a junior developer and then write a code review as a senior developer. So junior developer initially right off the bat goes down to 0.1, starting with precise code implementation. This is kind of a reverse of the other because we want deterministic output at the beginning. Then the senior engineer basically stayed in that mode, a very boring analytical low temperature mode, then decided to go up slightly for the actual technical critique instead of just this boring list of errors, so getting a little more creative. Then it actually all the way went up to 0.7 when it was being big bro, for lack of a better word. Great start, but these refinements would make it production ready. I really implore people who are senior developers to be kind to their code reviews. We were all juniors once, so be like GLM at 0.7 temperature if you ever need any guidance. Ping me for re-review. Very kind, very concise. Next one is the intuition, then proof. This one was interesting. It's a proof for the sum of 1 plus 2 plus 3 plus all the way to n equals n times n plus 1 quantity squared over 2. And the first task is to give 2 to 3 intuitive explanations that a curious high schooler, I don't know about this 6-7 generation, but maybe one back in the day would find satisfying, use analogies, etc., and then switch to providing a rigorous proof. So starting more creative, probably getting less creative and more analytical. So the handshake problem, Gauss's story, you're at a rockin' party with N people, including yourself. That's the example it gives. Then a visual staircase. And I thought this was actually particularly creative. I wouldn't have thought of that. But then the bookend pairing method, it actually is, I would say, slightly analytical for something you're giving to a high schooler to get them excited. Don't know what high school this person went to. But then it drops all the way to point one for the rigorous mathematical induction proof, and it does that pretty successfully. This one was also interesting. It was one I talked about earlier. It was basically write a 12-line poem about the feeling of debugging code at 3 a.m. and then analyze it, like a literary sort of analysis. So initially, right off the bat, temperature changed to 0.9. The monitor burns a crater in the dark, blah, blah, blah. And then goes all the way down to 0.1 for the literary analysis, the meter and the rhyme scheme, the metaphor and the imagery, and the emotional arc. This is like the best, most straightforward use case that I can think of for this sort of thing. And then we have, last but not least, story then JSON. As all good writers do, Hemingway, Jane Austen, basically what they do every time after they write a short story is they extract the information about their characters into JSON. So this started at 0.7, went up to 0.8 right off the bat, and it wrote a kind of creative science fiction sort of thing, then went all the way down to 0.1 and extracted the vendors in a JSON list. So you can imagine if J.K. Rowling was writing this, she would have her little diagonally JSON array of all the great things they sell at Burt's, Flurberglorts, or whatever the hell the store was called. So this is just a small sample of what could be done. Again, very interesting to see when the model decides to change. And I thought these were some very good examples of how different temperature can lend itself to different needs within a single response. One thing to note, though, is like GLM themselves, they actually just, I think, recommend keeping the temperature at 1.0 for most cases. So perhaps temperature means less than it did back in the day. I remember experimenting with like Open Router, their like chat room and stuff, or even just the Google AI Studio now. Temperature can matter quite a lot, but maybe that's becoming less and less relevant. I'll post the code for Thermostat on GitHub shortly. So why does this matter at the end of the day? It probably doesn't. Rather than having to sort of separate things, it sort of lends itself a little bit better to doing one-shot tasks. But I really did realize in sort of my day-to-day life, I kind of just fix on one temperature when it comes to like the coding agent, whatever other temperature it needs. The only place I really do play with temperature is in the Google AI Studio, which is vastly superior UI to Gemini. So if you're going to do something important with Gemini, not just talk to it, tell it your feelings, I highly recommend using the AI Studio, especially if you have the Google AI Pro or whatever, Gemini Pro plan. But there you can actually control things like temperature, top P. And so top P is going to be sort of my next experiment, my dynamic adjustment of the top P as things are generated. I don't think it will have as much of an effect as temperature, but again, super interesting just to see how these models themselves respond. The other thing I kind of want to also see is what if we call an external model either the same model but just with a fresh context, or a different model altogether, to sort of say, hey, here's what's been outputted so far, here's what it's going to do. Do you agree? Either ground it and sort of confirm it's the own model's desire for that temperature as being valid, or actually have it suggest the temperature altogether in the middle of the responses. In that case, we'd probably change the system prompt, calling the model, which is currently saying, hey, request a temperature change, using the tool call with just like, if you think you need to change temperature, call this tool and explain why, and then basically have the other model, the grounding model, have the context so far, as well as the model we're using's justification for why it thinks it needs a temperature change without a value, and then have it recommend back a value or just veto that change. A bunch of different ways to go with it. A bunch of them will make it even more expensive, but I just thought this was a super cool sort of task that was actually not that hard to implement. I did it in just a few hours, and yeah, super cool. Sort of learning a little bit how LLMs work while maybe doing it completely in a software engineering-ish sort of mindset. So the future of AI control, again, we get into things like meta prompting and agentic loops and sub-agents and orchestration. Maybe the best way to control AI is to let it control itself. Maybe it's not, because it'll take over the world. But I mean that just in the sense that like Perhaps the models know their own hyperparameter tuning methodology best, and we could either use an external model trained in the same way, the same family of models, or somehow, maybe if it's not going to be too poisoned with its own context, the actual model giving the response itself to dynamically tune these parameters. So that's Thermostat. I hope you like this video. Thanks so much for watching.